Alright, what's up guys? In this video we're going to pick up some vector calculus here. We're going to evaluate another line integral. So we're asked to evaluate the line integral 4x to the 5th ds, where c is the line segment from 1 comma 2 to negative 2 comma negative 1. So the first thing we need to do is to parameterize the line segment. So we'll begin by doing that first. So let's parameterize C basically. And so to do that, remember, that's just R of t is equal to 1 minus t multiplied by x sub 0 comma y sub 0 plus t multiplied by x sub 1 comma y sub 1. And remember that t here will be in between 0 and 1. Alright, so it's just going to be R of t. It's going to be 1 minus t multiplied by 1 comma positive 2. And this would be plus t multiplied by negative 2 comma negative 1. And it looks like this is just going to give us 1 minus 3t comma 2 minus 3t. Okay, so we have parameterized the line segment now. So x here, which would be the first parametric equation, will be 1 minus 3t, and the second parametric equation y will be 2 minus 3t. Now we need the definition for the line integral, so let me just quickly write that down. And by the way, I have plenty of videos on how to evaluate line integrals, so you don't have to just look at this one example. So check out some other videos if you need to, on my page and also on YouTube. Alright, so remember how we do this. You know, if we have a line integral f of x comma y ds, that's just equal to the integral from a to b. It's going to be f of x of t comma y of t multiplied by the square root of dx over dt squared plus dy over dt squared dt. That's the formula for it. Also keep in mind that you may not write it that way. Maybe the formula is written this way: f of x comma y ds is equal to the integral from a to b, and it'll be f of x of t comma y of t multiplied by the norm of r prime of t dt. So recall that these formulas are the exact same thing. They're just written two different ways, but they're sharing the exact same thing here. Alright, so I just wanted to make you aware of the two different ways that it's written, so that's to quell any type of confusion. Alright, so in our case, we got the line integral 4x to the 5th ds. First thing we need to do is to get dx over dt and dy over dt, so let's just get that right quick. So we'll get negative 3, and then dy over dt. Looks like we're also going to get a negative 3. So we got that taken care of. We know the limits of integration are going to be from 0 to 1, so we'll have 4. We'll stick in our parametric equation for x, which was 1 minus 3t. Don't forget that's being raised to the 5th power. And then I'm multiplying that by negative 3 squared plus negative 3 squared dt. I wouldn't get too worried about the square roots. Those are typically going to just simplify down to just a number, which is obviously a constant can be pulled out. So the square root won't cause you typically any problems at all. So we'll continue with the simplification here. I'll put it right here. Well, no, I'll put it right here because I need to look at it. Okay, so let's continue with the integration. So if we go here, we'll get the integral from 0 to 1, and I'm just looking back at our work here, and it'll be 4 multiplied by 1 minus 3t raised to the 5th power multiplied by the square root of 18 dt. So let's go ahead and integrate this. Remember, using some prime factorization, we can write the square root of 18. We can write that as 3 times the square root of 2. The 4 is a constant, so I'm going to pull that out as well. So I'm going to take out the 4. We can use some prime factorization on the square root of 18. So that's going to be 3 times the square root of 2. And then we'll have the integral from 0 to 1. And we'll have 1 plus, I'm sorry, not 1 plus, but 1 minus 3t, all raised to the 5th power, dt. I have to put this somewhere where I can, I'll just put it under. I don't need, I can do the integration without it. Okay, so if you don't know how to integrate this, I guess I can show you how to do it. We'll do just a simple u substitution. So we'll pick u to be 1 minus 3t. Then that means that du will be negative 3 dt. So we'll get negative 1 over 3 du is equal to dt. So recall that the 4 was pulled out, the 3 times the square root of 2 was pulled out. We're pulling out the negative 1/3 as well. That'd be times the integral. We're going to have to change the limits. And then here we'll just have u to the 5th du. Let's change the limits. If we change the limits, remember that u was 1 minus 3t, so we'll stick in a 0 and a 1. So that will be 1 minus 3 multiplied by 0, which gives me 1. And then 1 minus 3 multiplied by 1. And that gives me negative 2. So the new limits of integration, I'm actually going to simplify the constants on the outside here. We'll kind of take care of that. So this would be 12 times the square root of 2. This would be multiplied by negative 1/3. The limits of integration here are going to be, I'm going to flip the limits. So I'm going to bring the negative on the outside so that we can flip the limits. And if I flip the limits of integration, I have to change the sign of the integral. So this will be u to the 5th du now. So this is just going to give me a positive, so this would be 4 times the square root of 2. This would be u to the 6th power all over 6, evaluated from negative 2 to positive 1. So we'll get 1 over 6, and this would be minus 32 over 3 if we do the simplification, because that'll be 64 over 6, which we know we can reduce down to 32 over 3. So then we'll just have 1 over 6 subtract 32 over 3, which again I just reduced it, that's all I did. And that's negative 21 over 2 in my calculator. That's what I get if you're doing it with me. Maybe you got the same thing. This is what I got, by the way. And so now what we do is we take the 4 times the square root of 2 and we'll multiply it by negative 21 over 2. And this obviously just gives us negative 42 times the square root of 2, which are actually going to be your answer. So your final answer for the, and if you want to get that as a decimal, you can put it in your calculator, but it's really not all that necessary. So your final answer for this line integral here for x to the 5th ds is going to be negative 42 times the square root of 2. And again, I guess I can, just to satisfy your curiosity, I guess I'll just figure out what that is as a decimal. Yeah, it's going to be, I'll just take 2 spots. It'll be negative 59.39. That's a decimal. And that would be your answer. So let me circle that for you. And that's your solution. All right, so that's how you do it. Alright, so hopefully all of that made sense when I do the work. And if you guys have any questions about how I got my solution here, then just let me know. But I'll also obviously post a picture of my answers here. Alright, I'll see y'all next time. Y'all take care.